Hello everyone, I'm Shivnath Babu. Welcome to my talk on an AI chatbot for performance and quality. I'm co-founder and CTO at Unravel. I'm also an adjunct professor of computer science at Duke University. My work and research focus on the manageability of the new data stack and data pipelines. Unravel itself is a platform to simplify data ops, which is DevOps for the big data and the modern data applications. At Unravel, we have built this platform that can monitor, manage, troubleshoot all your big data clusters, which might be on-prem Hadoop clusters or Databricks and EMR clusters on the cloud. It brings together all the telemetry information about your applications, clusters, data sets, your platforms, and users in a single place. And from this data, Unravel creates rich and intuitive visualizations that can help you understand the performance, the quality, the resource usage of your entire platform in a single place. You can track and create reports on chargeback, on capacity planning, as well as detect anomalous behavior. And Unravel also uses AI and ML to automatically find out the cause of problems and help you fix these problems. So this talk is about a chatbot. And I'm sure all of you are very familiar with chatbots. You use many of them on a day-to-day basis. It's a program that can have a conversation with you. And why are we talking about a chatbot in the context of Spark? So in 2019, we demonstrated a chatbot for Spark. And this chatbot is meant for usage by Spark users. Many of you have seen the happy Spark user, the user who is very excited that her applications have been created, have been moved into production, and are creating value for a large number of users. At the same time, I'm pretty sure that either you or somebody that you know very well has at times been an unhappy Spark user, and unhappy because maybe the application that was created just failed and you just have no idea why it failed. Or the application that you moved into production was running well, but suddenly something happened and it's not fast anymore. It's missing its SLAs. How do you fix the problem that the application is encountering? Or maybe you have to migrate an application from a current on-prem environment to the cloud, and then you're just struggling with all of these choices of what node type or what data configuration to use on the cloud. And maybe you're already on the cloud and your costs are shooting up. You have no idea how to get them under control. So for such smart users, maybe somebody who's actually having a problem with their application that has failed and struggling with all those dependent stack traces and trying to find the root cause of a problem, in the Jeeves chatbot that we presented in the 2019 Spark Summit, you can actually just go and ask this chatbot, hey, like my app failed. I have no idea why. Can you help me? And the chatbot can take it from there. It finds the application. It can find the cause of the problem. Here the chatbot is saying that has found that executors running out of memory is what is causing the application to fail. And better, it can say how to fix the problem. And even better, it can actually show how the problem can be fixed and give a validation. So won't this be an excellent word? And that's what the Jeeves chatbot enabled. Let's quickly see the chatbot in action. So the chatbot we created using Slack. So this is a quick recording of the chatbot itself. So if you see the conversation that I'm having with the chatbot here, right? So my application, my CEO report application very specifically, is having some challenges. I want to make it run faster. So the chatbot immediately found, hey, that CEO report application was run a couple of times and it's telling me that these application IDs 163 and 176 were the runs of my application. And it's also confirming with me whether speeding up the application is a specific goal I actually want to achieve. And I've confirmed that that is indeed the case. And then the chatbot has come back to me and said, my application can actually be run faster by tuning a couple of options like the containers, the size of those containers I'm using in my application, right? And also it's asked me whether I can provide the exact command that I'm using to run the application. So I've provided the command, and then the chatbot is telling me here that has created a tuning session for me, a session that I can participate in and help get my application to better performance. Right? So let's see that in action. So here, as you can see, the two runs of the application that the chatbot had identified for me, those are these application 163 run and application run 176. You can see both of them here, and I can see the recommendations that the application has to improve performance. For example, you see here, there were recommendations around the sizing of these containers. On top of that, I can compare the performance of these applications at multiple levels. So here I can quickly check the different properties that were used, the configuration properties that were used, right? You can see that the Spark SQL Shuffle partitions, for example, I tried to change as I was kind of tuning it, but still the performance remains at around like 2.5 minutes in terms of running time of the application. The chatbot is further checked and found the configuration that can improve performance. And on top of that, it is using the command I gave it to try to run the application with the change configuration. And right here, you see the third run, the new run, the application run 189 is actually with the new recommended configuration. And clearly, the application with this new recommendation ran in half the time, right? So in addition to telling me how to improve the performance, the chatbot got me to a better place where my application is running 50% faster. And it's not only the improving the performance of the application in terms of the running time. Here I'm asking it, hey, my application page rank failed, right? And it found the run, the specific run ID that failed. And I can ask the chatbot to fetch the errors of the application. So if I ask it, hey, fetch the errors, right? It can immediately fetch all the error logs. So what you see right here are the driver and the executor logs, which were created for my failed application. Uh, and I'm sure some of you have seen such logs, right? They are pretty huge, right? It's stack trace upon stack trace, and users struggle to understand where exactly the application failed or what caused it to fail. So instead of having to look at logs like this, won't be great if you can actually go back to the chatbot like I've done here and ask it, right? Why did that application fail, right? Now let's see what the chatbot is able to do. Right? I'm asking my question right here. Why did the app fail? And lo behold, the chatbot is able to tell me that it failed because the Spark executors went out of memory, right? And it's further asking me, just like we tuned the application earlier for speed, do you want to make the application more reliable, get it running robustly, even if things like data sizes and everything change? So this is what we actually saw in 2019 with the Jeeves chatbot, right? Fast forward to 2021, right? There's a lot of interesting things that have happened. We actually had a pandemic, right? But on top of that, every company used the last a few years and all the data that is being collected from many different data sources to transform themselves to become data companies. Like if you look at the entire healthcare space, that was totally transformed by all the urgency coming due to the pandemic, from healthcare to transportation to finance or entertainment. Every industry, every vertical is really in the on the path to make or generate great insights from their data. And how are they doing that? They're doing that by creating data pipelines. So almost any company, if you look at it today, is at least running a handful, around 10 like data pipelines in production, which are powering their innovative data products. And where are these pipelines actually running? They're running on a new data stack. And let's see why a new data stack is required to run these pipelines. Because ultimately, the pipelines are taking a lot of diverse kind of data sources, right, which has to be captured. Sometimes batch ingestion happens. Sometimes these data sources have to be captured in real time, right? They have to be stored, and all these data sources could be huge in volume. They could be very diverse in in their nature, from structured, semi-structured to totally unstructured data, and then they have to be transformed through innovative algorithms, right? Sometimes involving very sophisticated machine learning and AI kind of transformations, then published and finally consumed as part of advanced analytics, BI, or real-time applications to power these data products. And altogether, it is this data flow that we refer to as a data pipeline. And a lot of companies are building very innovative data pipelines on a new data stack that has emerged over the past few years. Right? And this new data stack is multi-system, given how pipelines have very different needs along the different stages of the pipeline. Even something as simple as orchestrating, right, a few tasks on data. For that itself turns out to be an interesting and complex problem. We have new systems like Azure Data Factory, Fivetran, Airflow for this part of the pipeline phase. For the streaming aspect of the pipelines, where the stream data is ingested, processed, served in a real-time store to real-time apps. And we have systems like Fluentd, Kafka, Spark, Druid, MongoDB, and Pinot. For the data lake side to store all of these huge volumes and diverse data sets and to apply machine learning and advanced analytics on the data, we have systems like Databricks or storage systems like Data Lake and Azure Data Lake Store. We have Spark, or we have advanced SQL engines like Trino and Presto. For those of you who are more of the data warehousing side of the pipeline, you have systems like Snowflake or Redshift, or transformations can be done in a system like dbt. On the machine learning side of the pipeline, there are new systems like SageMaker, TensorFlow, PyTorch, or for storing all the diverse kinds of data and discovering them quickly. We have systems like Data Hub and Amundsen, and for all the features that have been created from this data, we have systems like Tecton. If you see, to power all of those innovative data products and run the data pipelines that actually feed and generate the data for these products, you actually need a collection of systems. And anytime you have applications that are composed of multiple systems, you know that there can be a whole bunch of challenges that arise, right? And the entire data ops practice has emerged in the past few years to enable pipelines to be run effectively and efficiently on this modern data stack. So we actually talked to a large number of companies to understand better how they manage their data pipelines. And we got a variety of interesting insights. So some of the companies told us that running the pipelines, especially on this new stack and with multiple systems that are feeding into the data pipeline, right? Problems can arise, problems in performance, problems in cost, problems in quality. And a lot of the time, the detection of these problems is very reactive. And worse, fixing the problems in these pipelines can take hours, if not sometimes days and weeks. And as these pipelines have become mission critical, SLAs on these pipelines have become very important. So missing an SLA can actually lead to penalties, right? And as more and more users have come onto these platforms, something or the other will actually cause a problem where the user is not being as efficient as they need to be. Now, on the other side of the fence, the operations teams often are complaining that these pipelines are not well tested. So there can be situations where the pipelines might fail, and that then causes all this problems around detecting and the time to fix. A lot of the companies actually told us that there is a problem in terms of the coordination. When are these pipelines getting scheduled to run? And if that schedule is not actually handled properly, we can end up with scenarios where the pipeline just cause artificial contention in the cluster. or in a cloud environment where nodes just scale up, right? And a lot more cost to be incurred unnecessarily. We heard a lot of complaints around not having the right quality data or not understanding when the data actually breaks, and that causes some issues with the correctness of the data product itself. Many companies are trying to migrate their pipelines from on-prem environments to the cloud, and that itself is challenging if the dependencies, all the dependencies for the pipelines, not captured correctly. And last but not the least, many companies want to move to a better place where there is very good CI/CD for their data and their pipelines, just like there is CI/CD for the software stack. And a lot of companies are also in a modernization phase where they have adopted these platforms, especially running on the cloud, and reducing the cost and running these platforms more efficiently is a top priority. If you look at all of these different kinds of use cases or questions that are coming up, right, you'll see that they all fit in the overall development lifecycle or the SDLC of these data pipelines, where the pipelines are created, often they are created by data scientists or data analyst, and then there might be a data engineer who's then tasked with taking the pipeline, moving it into production, which involves detecting problems, tuning the pipeline, doing the CI, right, and then deploying the pipelines in production, from where the operations teams take over the pipeline. They do the day-to-day monitoring operations, and sometimes some of the optimizations that need to be done as the data changes or more and more pipelines come on board, right? The overall feedback from running the applications in production comes back, and then the development teams might take on that feedback, update the pipelines, further tune them, and this entire process keeps going on. Right? It's a constantly running iterative process. And in this entire process, notice that there are multiple phases, there are multiple stakeholders who all have to coordinate to ensure that these different problems that we saw, which might be in one stage of this pipeline development or specific to one kind of stakeholder, right? They can all be addressed. And to do that, we actually need an effective data ops practice that has the holistic view of this entire development lifecycle and all the stakeholders that are involved. So they can coordinate accordingly, especially in an environment where not everybody might be an expert in all of these different stages. So to do that, that's where the data ops practice comes in. And what I'd like to show you in the rest of the talk is how we have created Unravel's pipeline observer to simplify this entire data ops practice for data pipelines running on the modern data stack. So from a 30,000-foot level, the pipeline observer works as follows. It collects all different kinds of telemetry data from all the different kinds of systems that comprise the modern data stack and power pipelines. Right? And the telemetry information might be in the form of logs or metrics or traces, right? Or they might be in the form of more structured events or in the form of configuration and metadata. So all of this information constantly streams in into the Unravel platform, where the pipeline observer is responsible for correlating the data and making it available in a real-time store. And from that store, there are these microservices, for example, a microservice for baselining or a microservice for detecting an anomaly in the run of the pipeline and then finding out what is the root cause of that. All these microservices further enrich the data in the form of insights, and all of them are served by the pipeline observer UI, right, which can be consumed by an API that can then power a chatbot, right? Or it can be used for proactive alerting when your pipeline is having a problem. On top of that, the pipeline observer can help track the SLAs, especially deviations from the SLAs. It can help with do very fine-grained cost chargeback for the pipelines and by relation to the data products that are running on top of these pipelines, or with the pipeline capacity estimation and planning, right, as things kind of change over time. So I would like to show you a demo. And in the context of this particular demo, what I've picked is a modern data stack where data pipelines are running on compute powered by Azure Databricks. The storage is on Azure Data Lake. And the orchestration is happening with Apache Airflow. The transformations are being done on DBT. We have data quality checks being run using great expectations. The chatbot itself is on Slack, like I showed you earlier, and the underlying insights and APIs are being powered by Unravel, which is end-to-end observability around data pipelines. I'll focus on three demo scenarios: a pipeline that is in danger of missing SLA, a pipeline that's having a cost overrun, and a pipeline that's having a data quality problem. So let's check it out in action. So back to the chatbot interface in Slack. So here we can see the first big change that we have done, where instead of having to ask and converse, here the interface is actually telling us that a particular pipeline, the reporting insights hourly pipeline, is actually running significantly slower than the baseline. Right? And one click, we can check out what is going on with the pipeline. So what you're seeing here is the pipeline observer UI, where the central part of the UI is actually saying the reporting insights of the pipeline. It's run, information about that run itself. Now, if you look at the right side, it's a live feed. And as you can see in the live feed, the pipeline run is delayed, right? It's actually significantly delayed. It's around 8 times slower than the baseline. The baseline itself is shown on the leftmost side. The baseline can be built from recent runs of the pipeline. It can be built from all the runs in a recent time window, or you can compare with a very specific run. So here from the baseline, you can see the duration of this pipeline is well less than a minute. The time is in milliseconds, right? But today's run is taking 8 times more. Right? So what is going on here? So with the pipeline observer, you can also see on the right side, there is a constant root cause analysis of performance deviation being run, being analyzed. And right here, it's telling us that the delay is actually happening in a very specific component that is being run as part of the pipeline. And you can click on the cluster activity to check why that problem is happening, which seems to be a delay. So let's check out the cluster activity. So what you're seeing here is a point in time of the execution of the pipeline. And you can see that this particular component here is running as part of the pipeline itself, the reporting insights hourly, but it's struggling to get resources and it's stuck in an accepted state. Right? And who's taking all the resources? The UI is also showing us that there's an ad hoc BI app that's running and that's taking all the resources, starving out the pipeline from getting the resources to run and finish within the SLA time. So notice how very quickly going from running a lot of different pipelines, understanding which pipelines are having a problem, and then understanding why that problem is happening, everything can be done intuitively using the pipeline observer interface and served up by a Slack chatbot. Let's check out the next problem. So this one is basically a problem where the pipeline is having a cost overrun, right? The pipeline job insight aggregate V4, its overall cost is very significantly different from baseline. So let's check out that particular run. So this is the pipeline observer showing the run of another pipeline, which is not only delayed, but worse is having a big cost overrun. So if you look at the corresponding baseline value, now we'll look at the cost. The cost is shown in cents. So this is around $2, which is what the pipeline usually takes to run. But today's run has already taken $12, right? 6 times more. And once again, we can drill down into the applications itself to understand which application is causing the significant overrun. And in one, at a glance, if you check out right here, right, you can see that the cause of this cost overrun is in the baseline, only 6 components are running as part of this pipeline. But in today's run that is having a cost overrun, more components have actually shown up. And this is a very common problem that we see where sometimes some changes are checked in the pipeline. Or it could be that like the data properties change, which is causing the query optimizer to pick a different plan, and that's causing a change of performance, and worse in this case, a huge cost overrun. So let's check out the third problem, which is even more interesting. And this is a data quality problem, right? Where the pipeline that's running is actually having an issue with data or correctness, right? As you see in the interface right here, this time the cost is okay, the application is running well on time, but it is having a quality issue. And we are using the great expectations tool where you can define what the correct quality and what the the assertions which will define the data actually to be of high quality and what they are. And right here, one of those assertions you can see has failed. And you can see on which particular table and which data set the problem is happening. So overall, notice how with the pipeline observer, the management of the pipeline from being some gigantic thing with a lot of different components has become much more easy and much more tractable. So this is what we have actually done over the last couple of years, looking at data pipelines running on the new data stack and seeing and understanding all the different challenges that data teams face in running these pipelines and seeing how we can bring together AI-driven data ops practice powered by a tool like Unravel in conjunction with a bunch of other tools in the ecosystem to enable pipelines to be developed and managed with these while saving you time and money. We'd love to get your feedback. Please sign up for a free trial at this particular URL. We are definitely hiring. We would love to have all people who are passionate and interested in these problems working with us. These are pretty hard and interesting problems. And last but not least, your feedback in the talk is very important. Thank you.